Today we are repairing a vehicle with a high temperature fault code. The vehicle suddenly threw multiple fault codes while driving. It indicated high coolant temperature, so we had it towed back directly. Now the dashboard displays check thermal management system. First, we use the scanner to read the fault codes. Let's check the report. We can see the VCU3 Vehicle Control Unit reports faults related to electric water pump short circuit. Now open the engine hood. First, check if the coolant is low. We can see the heater coolant level is normal. Now let's move the camera over here. The coolant expansion tank is also full. This vehicle does not rely on a fan for cooling. It uses a water pump to circulate coolant for cooling. In this case, we will now use the scanner to activate the electric water pump to see if it operates. We go directly into VCU system. Then select Special Functions. Then enter the water pump bleeding routine. This will activate the electric water pump. Ignition switch is on. We tap OK. Routine execution failed. Let's try again. Routine execution still failed. Communication is normal. Routine execution failed. Now let's check if power is reaching the water pump wiring. Let's locate the water pump. The water pump is located right here. This is the electric water pump. First, disconnect the wiring connector to measure if there is a power supply. We have unplugged the connector. As you can see, it is disconnected now. Now we start measuring. There are 3 wires, 1 positive wire, 1 negative wire, and 1 signal wire. Now let's check if there is power on the positive wire. The middle wire is positive. No power. Let's measure again between positive and negative. As you can see, there is still no power on the meter. Now we trace this wiring upward. Following the wire route, we can see that the wiring eventually leads to the fuse box. According to the data, this is the fuse. This 15A fuse. We find this 15A fuse has power on one side. Power on one side, no power on the other. Preliminary judgment, this fuse is faulty. Now we remove the fuse to test it. Set the multimeter to ohm range. Use the multimeter to check continuity. We can confirm the fuse is blown. Now we replace it with a new fuse and test again. We have installed a new fuse for testing. As you can see, the fuse is good. Now we install the fuse. We measure again. Voltage is 14.25 volts. Power on both sides. The fuse is good. Now we reconnect the water pump connector. Plug it back in. Then perform a test. We have just replaced the fuse. Now let's activate the water pump again. It can now execute. We can hear the sound of coolant circulating. Now the water pump has stopped working again. Execution failed. It worked at first, but suddenly failed again. Let's try once more. It failed immediately again. Now let's check the fuse again. Because during testing we heard a pop from the fuse. Now we can see power on one side of the fuse, no power on the other. The fuse is blown again. Let's replace it with another one and test. We have installed a good fuse and measured again. Voltage is normal. Check the other side. Also normal. The fuse is installed properly. No issues. Now we use the scanner to test again. Let's run the bleeding procedure again. It has started. At first, we can hear the water pump running. The tank is making gurgling noises. We can see the coolant flowing here. It stopped again. Let's check the scanner. The routine is still running on the scanner. Let's see if it can complete successfully. Execution failed again. Check the fuse again. See if it is blown. Every time the water pump runs halfway, it cuts out. We are not sure why. This is the fuse we just removed. It is faulty. Now replace it with a good one. This one is good. Now install the good fuse. Let's test again. Make sure it does not blow immediately after installation. Power present. The other side also has power. This shows the fuse is good. No problem. Let's run the procedure again. If it blows again, it is very likely the water pump is seized, causing excessive current draw which blows the fuse. As you can see here, the water pump is running. It stopped again. Stopped again. Execution unsuccessful again. There is no need to continue testing. Let's check the fuse first. See if it is blown. Power on one side. Check the other side. No power on the other side. Let's take a look. Remove it to check. Confirm if it is blown. The reading is infinite. This means the fuse is blown. There is no need to waste more fuses by installing them for testing. We will replace the water pump directly to see if the same issue occurs. This hose, this connector and a bracket here. 1 bolt on this side of the bracket, 1 bolt on this side. Now we remove it directly. First, we gather the necessary tools. Second, we drain the coolant first. If we do not drain it, coolant will spill everywhere. When we remove the water pump, we have drained the coolant. Now we start removing the water pump. Disconnect the hoses. Now we can take out the water pump. This is the water pump. We will replace it with a new one right away. This is the new water pump we just got. Now we prepare to install it. Install the old mounting bracket onto the new water pump. Tighten the bracket bolts. Install the new water pump onto the vehicle. Tighten the bolts. Connect the hoses. Reconnect the wiring connector. New water pump installation complete. Now add coolant. Water pump is in place. Coolant has been added. Now we use the water pump bleeding function again. We start directly. Water pump bleeding routine. Let's take a close look. The water pump is running. Let's see if the routine completes successfully. During execution, the water pump runs continuously. We see VCU water pump bleeding executed successfully. Normally, after replacing the water pump, we run the bleeding routine 2 to 3 times. We can run it once more to ensure the water pump is working properly. Execution successful. Now we scan all systems. Next, we read the fault codes again. Let's check. Now, there are only 2 communication faults. No water pump related faults. Fault resolved. Next, we will perform a road test to see if the water pump fault reappears. To see if overheating occurs, we need to verify with a road test.